Okay, we are at section 9.7, systems of many particles. Let's go to the PowerPoint, and we see the equation here. The uh, velocity is the time rate of change of position. So the velocity of the center of mass is the time rate of change of the position of the center of mass, dr cm dt. Well, what is the center of mass? It's 1 over m times the sum of mi dri, in this case dri dt, because it's we're taking the time rate of change of the center of mass. So we see that the velocity of the center of mass is 1 over the mass times the sum of all the mv's. Well, the mv, all the mv's are, that's really the, if we multiply m times the v of center of mass, which we started at the beginning, all we get is the sum of the mivi's, which is the sum of all the momenta. So it's the total momentum. The mass times the center of mass velocity is the total momentum. And the acceleration is the time rate of change of velocity. So we see acceleration of the center of mass is dvcm dt equals 1 over the mass times the sum of mi dv dt, and that's equal to 1 over the mass times the sum of mi acceleration I. Well, we do the same thing, mass times acceleration, that gets rid of the 1 over the m. Well, the sum of the mass times acceleration, that's the sum of all the forces, both internal and external. But if we using Newton's third law, for every force there's an equal and opposite force. So we can take all of those forces that are internal, and they'll all cancel out because they're all equal to the negative of their opposite. So what we're left with is the net external force. So the net external force, the sum of all the external forces is equal to mass times acceleration of the center of mass. Let's see if there's anything I need to show. The net external force on a system of particles is equal to the total mass of the system multiplied by the acceleration of the center of mass. Okay, the center of mass of a system of particles having combined mass n moves like an equivalent single particle of mass m, the way it would move under the influence of the net external force on the system. The center of mass of a system of particles having combined mass m moves like an equivalent single particle of mass, the way it would move under the influence of the net external force of the system. So the integral of the external forces dt is equal to the mass times the acceleration of the center of mass dt. Well, the acceleration is dv dt, the time rate of change of velocity. And so that gives us the mass of the, we take the mass out of the integral sign because it's a constant, assuming that constant mass. We won't be able to do that when it comes to rocket propulsion. The mass times dv center of mass dt, and so we're left with the mass times the change in center of mass velocity. Well, we can write the equation delta p total. The change in total momentum is equal to the impulse, force times time. The mass times the acceleration of the center of mass is equal to the, let's see, that's equation 2. The impulse is imparted to the system by external forces. So P total is the total momentum of the system. Now, if it, this is for a non-isolated system. If the system If the net external force on the system is equal to 0, the system is isolated. And that's when we get this equation: the mass times the acceleration of the center of mass is equal to the mass times dVcm dt equals 0. That's an isolated system. So the total momentum in this case, if it's an isolated system, the total momentum, the change in total momentum is equal to 0. So the mv center of mass is equal to the total momentum, which that is constant when the sum of the forces, external forces, is equal to 0. Like, when do we have that? Well, you can think of a cannon and a cannonball. You have a cannon, you have put a cannonball in. What is the total momentum of the system before you fire the cannon? 0. They're both still. You fire the cannonball goes in one direction, and the cannon goes in the other direction. You have mass times the velocity, a large mass times the velocity of the cannon, times the smaller cannonball times the velocity of the cannonball should be much faster. They'll be equal and opposite, and so the total momentum is equal to 0. You can also think of think of a swimmer on a raft. When he dives horizontally, he's going to push on the raft, so the mass times the velocity of the diver will equal the mass times the velocity of the raft. They'll go in opposite directions. This is why we have recoil. If you've ever shot a rifle or a pistol, you know about recoil. Okay, let's look at a quick quiz. A cruise ship is moving at constant speed through the water. The vacationers on the ship are eager to arrive at their next destination, so they decide to try to speed up the cruise ship by gathering at the front, the bow, the bow, and running together toward the stern, the back of the ship. While they are running toward the stern, the speed of the ship is higher than it was before, unchanged, lower than it was before. It's actually higher, but by just a small amount when you consider the mass of the ship. So it's higher than it was before. It's just like the swimmer diving off the raft that I mentioned. The vessel passenger system is isolated, so if the passengers all start running one way, the speed of the vessel increases just a small amount the other way. Now, same situation. They tried to speed up the cruise ship by gathering at the front and running to the back. The vacationers stopped running when they reached the stern of the ship. After they have all stopped running, the speed of the ship is higher, unchanged, lower, or impossible to determine. Well, it's actually unchanged, because the momentum, once they stop running, the momentum of the system is the same as it was before they started running. And maybe they want to do it several times. So they go back to the bow of the ship and run back. Well, every time they run to the front, they're having the opposite effect. So it really doesn't change. When they run back to the bow of the ship, the front of the ship, they slow it down, and then they can run to the back and speed it up. But it's a canceling effect. Okay, with that, we're gonna next discussion will be deformable systems.